So today will be the last lesson that's on the quest. Okay. And it starts with 14, which was where we started talking about exponents. Okay. So it's going to be mostly about exponents and radicals.
There's a way we could flip-flop the Tuesday and Thursday there so we don't learn two full lessons that won't have the quest prior to the quest.
Let me take a little survey. So my reasoning for putting a day between the last lesson we covered and the quest is because I don't want to test you on something I taught you the class before, right? So like you're going to learn 18 on the 22nd, and then the next class it's going to be on the quest, right? So there wouldn't. Yes, that's true. Yeah, that's true. So you would have a little chance to ask questions on that material right before. So I'm not opposed to that if that's something that people are interested in. Right.
Right. Well, today's Thursday, Friday, Saturday, Sunday, Monday, Tuesday.
Yeah. So if you wanted to take it Tuesday, like before class, that would be fine with me. Do you have any time that you could come in before or after?
I don't have any.
Yeah. Yeah. Yeah, I understand the request, but I don't want to. I mean, I have reasoning for doing it that way, and I think that giving people the schedule ahead of time is to allow them to plan their semesters, and I think that changing it is just going to mess some people up. So I'm happy to let you take it early. You can take it today if you want, right after class. But yeah, I think I'm not going to. Okay, then we'll leave it. But again, if you want to take it early, I'm happy to let you.
Sure. Great,
Okay.
thank you.
Yep. All right, so today we're going to start. We talked about the beginning. We talked about lesson 17 at the end of last class, and we talked about the relationship between radicals and exponents. Okay, so to remind you, roots go in the cellar, right? That's like the main theme of what we did last class. When you have a power on an x, it goes in the numerator of the exponent, and the root goes in the cellar. It goes in the bottom of the fraction. So this formula that we put lots of stars around, the nth root of x to the k, you can rewrite as x to the k over n. So we did several examples. So rather than redo them, I was thinking that I'm going to jump to one of the examples in your activities to help get you started, and we'll do it together. So I'm going to do B with you here. Okay. So 25 to the negative 1/2. So in general, when you have a negative exponent, it's a good idea to deal with the negative exponent first. Okay, so what does a negative exponent tell you to do? That's the root. That's the fractional part. But aside from the fact that that's a fraction, it's negative, right? So negative exponents tell you to move, right? Negative exponents like the crying baby. So this baby is unhappy. It should move to the denominator, right? It's got to go down for a nap. So that becomes 25 to the positive 1/2. And what goes on top after I moved that 25? 1. Good. All right, now I can look at the 1/2 exponent as a power and a root. Okay, so which number is the root? 2. Yeah, the 1 over the 2. The 1 is the power, the 2 is the root. So I'm taking 25 to the first and the square root of that, right? So typically when we're taking a square root, you don't have to put the little 2 there, but just so that you can see exactly where those two numbers went. Write it for now. All right, so this becomes 1 over 25 to the first is just 25, and the square root of 25 is 5. 1 over 5. Yeah. Yep. It's got to be 1 over 5 because of the negative exponent. All right, so that's one dealing with just numbers. And then I want to jump to number 4, part B. So page 132, I'm going to do this one with you also. Okay, so there are lots of approaches here. So whatever I do is not the only way to solve this problem. As long as you're following the rules of exponents, you're good. So when I have, this is everything in parentheses there is just multiplication and division, right? The fraction bar means divide. The things on top are being multiplied. The things on bottom are being multiplied. So this really nice rule that when you're dealing with multiplication and division, everything has to get raised to that -2 power, right? It looks like the distributive property. So this looks like 2 to the -2 times p to the 1/2 to the -2 over 3 to the -2 times p squared to the -2. So now let's simplify our powers to powers. Any place I'm raising a power to a power, I'm going to simplify it. So I have p to the 1/2 to the -2. What do you do when you raise a power to a power? You multiply the exponents. Yeah. So I'm going to copy the 2 to the -2. And then 1/2 times -2 is -1. Copy the 3 to the -2. P squared to the -2, I multiply the exponents and I get p to the -4. And then the last thing I'm going to do is deal with the crying babies, right? Move them to their opposite location to make them happy, right? So these guys have to move down to 2 squared p to the 1st. These two move up and become 3 squared p to the 4th. So 3 squared, I can simplify to 9. And 2 squared becomes 4. And am I done? Should I circle it? Yeah, p to the 4th over p. What does that reduce to? P to the 3rd, yeah. Because that's really a p to the 1st. And when you have like dividing like bases, you can subtract the exponents. So it becomes 9 p cubed over 4. All right, so that's a couple of examples to help get you started. I'm going to have you jump into the activities now. So you can go start at the beginning and let me know if you, of course. Okay. So we're going to simplify some more radicals, right? And that come from the quadratic formula. And then we're also going to do some multiplying of polynomials using the box method. So very soon we're going to be covering something called the quadratic formula. You may or may not have seen it or heard of it. It looks like this. It says x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And a, b, and c are just numbers that you plug into that formula. Okay. So once you plug into that formula, we're going to need to know how to reduce and simplify solutions of this form to lowest terms. So here's an example. And in your packet, it's all written out. You can, copy down what I'm doing on another page or just follow along on your packet. So I've got -16 plus or minus square root 128 over 8. So first thing I want to do is simplify the radical. Okay, so we learned how to do this in a previous class. So most of what I'm doing here is bookkeeping, right? Most of what I'm doing is copying from the previous step, and I'm going to do like one small thing to simplify. The square root of 128. Okay. So I want to rewrite, first of all, is 128 a perfect square? No. So you look at your perfect powers table, you search for 128 in the squares list, it's not in there. Okay, it's not in there. So instead, you say, okay, are there any numbers in the squares list that can divide into 128? Yes. Which one? 64 can go into 128, right? And 64 is a perfect square. So I'm going to rewrite 128 as 64 times 2. Okay, so that's all I did is a rewriting. So then I have negative 16 plus or minus. I can take those two square roots separately. So I have square root 64 times square root 2 all over 8. And then the square root of 64, what is that? 8. So in my next step, everything gets copied, negative 16 plus or minus over 8. And then instead of a root 64, I write an 8 because they're equal. And of course, I'm out of room. Jump to another page. Okay, so now I can break this fraction into two fractions, right? So I can make that fraction plus or minus that fraction. So we'll talk about why that's true once I write it down. 16 over 8 plus or minus 8 root 2 over 8. Okay. So the reason this is allowed, I think of it as sort of like the reverse of adding fractions, right? So once I break it into two fractions that have the same denominator, right? The rule for adding fractions that have the same denominator is you just add the tops, right? And you leave the denominator in 8. So that's what this is. The tops are added and the denominator is 8. Okay, so I think of it as like the reverse of adding fractions. Then you reduce each fraction. So negative 16 over 8, how does that reduce? Negative 2. And 8 root 2 over 8, your 8's cancel, and you just get root 2. Okay. So this actually means there are two different answers. That means that negative 2 plus root 2 is an answer, and negative 2 minus root 2 is an answer. So the plus or minus is just a way to save you some writing. It actually means that there's two different numbers are the answers. Okay, so we're going to change gears a little bit and talk about multiplying polynomials. Okay, we're going to learn this box method. It's very general and will help us with an important upcoming topic called factoring. So if I want to multiply 4x cubed y to the 5th by this whole mess, negative 3xy squared minus 7x cubed plus 2x squared y, we set up this box. Okay, so you put one factor along the left to be like the height of the box, and you put your other factor, negative 3, blah, 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 that whole long thing, along the width of the box, right? So you're doing length times width. When you do length times width of a box, that is the area of the box, right? Okay, so we set up this box and we find the area of each small rectangle by multiplying its length times its width. Okay, so if I want to multiply, I'll do each of these in different colors. This guy times this guy. So you multiply the numbers, right? So just look at the numbers. 4 times negative 3, what do you get? Negative 12. Okay, next we look at the x's. X cubed times x to the first. What is that? X to the fourth. Yeah, x cubed times x. You have like bases, you add the exponents. So that's going to be x to the fourth. And then the y's, y to the 5th times y squared, y to the 7th. Great. And then we do the next box. So I have multiply the numbers. 4 times 7, 28. X cubed times x cubed, x to the 6th. And y to the 5th times, there's no y there, but you can just imagine there's a 1 there, right? What's y to the 5th times 1? Y to the 5th. And then I've got this this subtraction sign, so I should copy that. Subtraction sign. All right, and then finally, I do 4x cubed y to the 5th times the last term of the second factor. Multiply the numbers. 4 times 2 is 8. X cubed times x squared is x to the 5th. And y to the 5th times y is y to the 6th. And there was a plus sign there, so I copied that down. And then finally, we should write our answer in like normal mathematical notation, not in the box, right? So I should say, when you multiply this guy by this guy, so that's this times this, you get negative 12x to the 4th, y to the 7th, minus 28x to the 6th, y to the 5th, plus 8x to the 5th, y to the 6th. So those are just all the things from my boxes.
And then that's the answer because there aren't like terms to combine.
Correct. Yep. No like terms to combine there. If there were, we definitely would do that. All right, let's try another one. It's a little bit simpler looking. I've got 3x minus 4 by negative 2x plus 5. So I'm going to set up boxes. Each term, right, and terms are separated by addition and subtraction. So each factor is made up of terms, and each term gets its own box. So here I'm going to put 3x minus 4. I'll put that along the height. And then along the width, I'll put negative 2x plus 5. So I think I'll put that plus with the 5. Negative 2x plus 5. And then you multiply each, find the area of each little box by multiplying. Okay, so 3x times negative 2x, negative 6, and x times x is x squared. Yep. 3x times 5, positive 15x. Negative 4 times negative 2x, positive 8x, good. And negative 4 times 5, negative 20. So I've got all these terms, right? I have to add them all together, and that's my result. Okay, so in part C here, I'm going to write down all the answers from the entries in my box. So I have negative 6x squared plus 15x plus 8x minus 20. Okay. And then, like Sarah pointed out in the last one, I didn't have any like terms, but in this one I do, right? I've got a 15x and an 8x. Those can be added together. Okay, so my last step is to do that. Negative 6x squared plus 15 and 8 is 23 minus 20. Okay, so one quick note about the dimensions of the box. The number of rows of the box is the number of terms in the first factor. And the number of columns in the box is the number of terms in the second factor. And that word terms means the things that are separated by addition or subtraction. So let's look up here. So in the first example, my first factor, the first thing that was being multiplied, it just has one term because nothing is separated by addition or subtraction. So this guy just has one term. The second factor, right, I'm multiplying by all of this, right? That's a factor, what I put in green there. It has three terms because there's 1, 2, 3 things separated by addition and subtraction. Okay. So each term, when you're setting up your boxes, each term of your factor gets a box. So one more example. If I want to multiply negative a minus b plus c times d minus e minus f plus g, I would make a box that has 3 rows because there are 3 terms in the first factor, and 4 columns because there are 4 columns in that factor. So I could do it real quickly. Rows, I would have minus a, minus b plus c. That gives me my 3 rows. Okay, and then my columns, I need a d minus e minus f and g. So each term gets a column. That's how you set up your boxes. Okay, so since this is on your next quest, we should probably spend class time doing these activities, even if you didn't finish the ones before. And then,
Right now,
sure. Yeah, we can look at A. So negative 10 plus or minus root 75 over 5. So mostly I'm just copying. I write negative 10 plus or minus over 5, a square root. And then I just want to, first I ask myself, is 75 a perfect square? No, I can't take the square root of 75. So instead I'm going to try to simplify it by asking myself, are there any perfect square numbers that are factors of 75? 25, yes. So I could rewrite 75 as 25 times 3. Right? So then in my next step, again, this is mostly just copying. I just broke that square root of radical 25 times 3 into 2 square roots, radical 25 times radical 3. And then I can actually take the square root of 25. So I get negative 10 plus or minus. Square root of 25 is 5. Break that into 2 fractions. So I get negative 10 over 5 plus or minus 5 root 3 over 5. And reduce. Negative 10 over 5 is negative 2. Over here, the 5's cancel, and I just get root 3. Negative 2 plus or minus root 3.